Hello everyone, and welcome back to the series of friends of mine buy very interesting stuff and send it through me and I get to make videos about it. This right here is a GTX 970 Omega, or maybe Extreme Omega. I'm not entirely sure what the name of this is. It didn't come with the original packaging, but it is pretty obvious though that it's a Zotac GTX 970, and it's rather big. Because, oh, actually it has a sticker on the back. It is a AMP Omega. Okay, so it's an AMP Omega. Yeah, anyway, so this is basically Zotac's take on an, yeah, kind of. It has an LN2 switch right here, so I guess this is Zotac's take on an Extreme Overclocking GTX 970. I don't really have that much experience with Maxwell. I have that one E-powered 970, which was very fun. It's basically like Kepler, but a little bit less current draw and therefore a bit more scaling and a bit easier to run. So I'd love to do more Maxwell if I could, but well, I don't really have that much money to spend on it. This card was picked up by Deepa, and he paid 135 euros for this, which is an okay price, considering you pay around like 120 euros for a 780 Ti, and this one has a more VRAM and is not exactly the same amount of raw power, but with newer APIs and stuff around the same performance. So it's an okay price, especially considering that this is a very, very rare model. It's another case like the 560W HDI. I didn't know that this existed. Zotac is really cool with their custom cards. So basically, if you like, most cards that Zotac makes are like trash because they use reference PCBs and then use pretty cheap coolers. But sometimes Zotac makes custom cards. They are usually only available in the like Asian and Chinese market, but sometimes they are available here in Europe or the US as well. And this is one of those. So yeah, and these are really cool, and I want to show it off in this video. So first of all, I want to talk a bit about the heatsink, because it kinda reminds me of, so I don't know how good the heatsink is, but like 970s don't pull a lot of power, so it's probably fine. But still, like this is like a 2.5, maybe passes just about as a 3-slot heatsink. But if you look into it, you can't really see it because of that cover. If you look at it from here, so for all that thickness, that's not really that much heatsink. That's like about 1 slot worth of heatsink, which I mean is fine. We have at least 4 heat pipes, possibly more on the other side. Yeah, there's 2 heat pipes going left, so we have a total of 6 heat pipes, which that's like pretty adequate. Like this heatsink is gonna perform just fine for a 970. I still think though that that's not a whole lot of fin stack. Also, these fans look suspiciously close to these fans. So this is also a Zotac branded heatsink, but actually that's a Zalman VF3000 that Zotac just slapped their name on, and these fans look just like those. So maybe this is just a Zalman made cooler. But yeah, I mean it looks really cool. I really like the shroud. I also like this, like if the card sits in your case, like if you mount it normally, you kind of see this part, which looks really nice. I would have just wished to have a bit more fin stack, because like this is an extreme overclocking card. It's supposed to be over the top, and yeah. Anyway, it's mostly just nitpicking. Like again, the heatsink is probably just fine. Okay, let's take a look at the PCB. I kinda know what to expect, since it's a like Zotac has a very Zotac way about doing their custom cards, which usually involves the philosophy of more phases, more better. So I kind of know what to expect, but I don't really know what specifically to expect. Okay, the screws should be loose. The backplate's just about thick enough to make it kind of a pain to get them out of there. It's also really nice to see a backplate on a card like this. Like, backplates became a thing around like the 700 series, but really only on like really high-end models. Okay. Oh, this is the VRM heatsink. Interesting. That thermal paste is probably not factory. Ooh, oh. 2 more screws that came out. And there's 1 left. Yeah, we don't want to lose those. Okay, so yeah, here's another look at the heatsink. Like, 6 heat pipes, that's plenty for 970. And again, like, it's gonna be just fine. Just, yeah, would have been a bit more, would have been nice. I like the part that they use this part as heat sinking for what's probably the memory VRM. And then vCore has its own heatsink. And they also have a, okay, they did that on the 780 Ti that they made. They just kind of slapped a steel plate onto the memory. Like, it's better than nothing, but this is not gonna stop the memory from overheating, it's just gonna delay the effect. So yeah. So how do we get the... So it looks like we first have to remove the backplate. And then we'll get access to the memory plate and VRM heatsink. Which is a bit annoying. Then, again, it does make sense. Like, it does make sense for extreme overclocking. Then the memory plate also makes sense, because that probably clears... well, actually, does it? It might just about clear an LN2 port. So in a perspective of the card being made for extreme overclocking, that's actually fine. Because then you can run the card without the backplate and still have your memory and VRM cooling. That's the backplate, no thermal pads there, not that I really expected to see any. Oh, it's a bit dusty. But it's fine. Yeah. So yeah, it does make sense to build the card like that, because when you when you do sub-zero overclocking, most of your PCB, especially the backside, like turns to ice. And you don't want to have a backplate that covers that, because then you don't know when when you have potential water buildup, you want to see that. And you potentially want to be able to get in there with like a towel to catch any water droplets before they reach anything that they shouldn't reach. Okay, gotta be careful. Okay. We have Samsung memory. Samsung cideo should be 4 gigabit on this. Oh, power stages. Or maybe just the AMOS. Okay, that's actually not what I expected. What are those? Those are some on semiconductor thing. Are those NCP 5369s? Uh-oh. Yeah, those are NCP 5369s. So it is a DRMOS, and it's like one of the worst DRMOSs, if I remember correctly. Because the NCP 5369, I've seen this before. So this is a... I have to recheck. I think it's a 35 or 40 amp DRMOS. These were used on the GTX 970 Jetstream from Palette as well, just that the Jetstream had a 4-phase and not a 1, 2, 3, 4, 5, 6, 7, 8 phase like this one. So this VCore VRM is probably still fine with the AMOSs as weak as those. The Jetstream, however, is not. There's so many of those that have, like, at least the Jetstream has fuses. There's so many of those that have the fuses blown because one of those VCore AMOSs went up in smoke. Actually, I had one of those that had that thing happen, and I actually sort of fixed the card. I removed the dead AMOS. I bought some replacements, tried to solder it on, and then that's the point where I popcorned the PCB because I was very, very bad at anything with hot air at the time. So that's why that 970 doesn't work, because the popcorning like killed the card. I tried e-powering it, doesn't work. Anyway, so the VCore VRM looks pretty like it's a typical Zotac design. It looks very impressive with all those phases you have. But in reality, it's like an okay VRM, but like it's nowhere near as insane as it might look. Because, yeah, not exactly got a lot of amps per phase. And also, that's probably not 3-phase memory. I think one of those, we can check that with my multimeter. That's another thing that Zotac likes to do. Which is make fake inductors. So let's put the card on the back. Because, so basically what I'm expecting to see here is you see these two inductors. They are pretty obviously the input filtering for these two 8 pins for 12 volts. And we also get 12 volts from the PCI Express slot, but you see the absence of any sort of input filtering inductor around the PCI Express power slot region. Now, that totally just could be no inductor for input filtering, which wouldn't be recommended, but you can do that. You're just gonna have like the transients your cards produced, like translate back into the power supply and everything else that's connected to the same power rail. But yeah, I'm pretty sure that actually, if I look at the power plane, it kind of looks like there's that these two is probably memory, and then that is probably our PCI Express 12 volt. Yep. And then these two don't beep because those are actually memory. And then this one is our 12 volt input filter inductor. So no, it's not a 3-phase memory. You also would have been able to tell that by just the amount of MOSFETs that we have here. But that, yeah, also it has a shunt resistor right next to it. That's also another giveaway, because that's for the power monitoring. As you can see here, there's more shunt resistors here for the power monitoring. And then over here we have the INA3221. On 900 series, oh, I'm not actually sure if you can do it on 900 series. I know you can't on 10 series, and I know you can on 700 series. If you just remove the INA3221, the power limit is just gone. On 10 series, it locks the card into safe mode. I'm pretty sure it works on 900 series, but I don't know it for a fact. But yeah. And I guess for the MOSFETs for memory are just some MDU FETs. No, actually, those are... I can tell what those are. It's a P3054M, and then the other one... those are the same. Wait, did they use the same model of... Oh no, M3054M. Okay, it looks like all of these 8 MOSFETs are exactly the same model. You can do that. Again, it's not recommended because like your high side MOSFET is supposed to be like really fast at switching, and your low side MOSFET is supposed to be great at handling current. You can get MOSFETs that can do both. They are very expensive. So usually when you get discrete MOSFET VRMs, you get high sides that don't do a lot of current but can switch pretty fast. And then you get low side MOSFETs that don't switch that fast but can handle a lot of current. And low side MOSFETs also have low RDS on resistance, which makes the VRM more efficient. And also run the MOSFETs colder. So yeah, it's another very Zotac thing. But yeah, so yeah, typical Zotac things. This is a 256 memory bit bus. Those MOSFETs are fine. It's just, you know, it looks cheap, and it probably is, because that's the thing that Zotac does. The RMOSs are also probably like rather cheap. Like they look impressive because everyone knows, oh, those look like power stages. Power stage is good, and also 8 of them. This must be a very strong VRM. But then you look at what they are, and then not that great. So what vCore controller do we have? It's another unsemiconductor one. Is that just a 4208? NCP 4208. Yep. That's the same controller that the 780 Ti WindForce uses. And I think also the 980 Ti WindForce uses. So that's basically an 8-phase version of the NCP 4206, which is what you get on like a GTX 780, 780 Ti, and I think also the 980 Ti reference PCB, which is probably not the most high-end controller of the time, but like it's a, at the time, like somewhat high-end 8-phase voltage controller. I think it does some I2C functionality, so you could, like, at least the 4206 does it, so there's like, why wouldn't this one? So you could potentially hook up an EMC2 to this and get like voltage control without having to volt mod the card, which is pretty cool. Yeah, so the controller's fine. I would have selected better the RMOSs. Honestly, if you ask me, like at the time, I would have just gotten IR3555s and then swapped this one out for like an CHA8318. That's probably what I would have done, but yeah, Zotac made their own decision. And again, it's a GTX 970. There is some 980 Ti that uses the same DRMOSs for its vCore VRM, but I don't know how many it has. If it also has 8, then that would be bad. Yeah, I'm pretty sure that 980 Ti uses more than 8. Yeah. Also, do I have anything to... I just used up the last bit of toilet paper today when I was cleaning out my water cooling loop for the test bench. I have a little bit left over here. Just want to take a look at the core and wipe up that clearly aftermarket and unknown brand thermal paste. So I mean, yeah, it's a GM204 200A1. It's a 970. And yeah, so the last part that I want to talk about is the output filtering, because this is rather nice. So one thing that Zotac does a lot now in current generation is just like use a lot of high capacity CAN type capacitors, which again is a valid thing to do. It's just a very cheap and ineffective way of doing things. So I'm rather surprised that we're not seeing any CAN type capacitors for the output filtering on this card. Instead, we're getting 470 microfarad SMD polymer capacitors as well as some multi-layer ceramics, which is really nice. And we get like 1, 2, 3, 4, 5, 6, like 12 of them on the front. And then on the back, that's probably memory. Then we get another like 13, 14, 15, 16, 17. And then under these three, you can kind of see that they're like daughter PCBs here. So I think these are meant to look like they are prod lasers. Also, there's more capacitors here, and I lost track of how many there were. But yeah, all of these are 470 microfarads, which is very nice because usually, like on like cheap designs, you usually get 330 microfarads. These here have 470 microfarads, so more capacitance per capacitor, which is nice. Some cards also use like 560 microfarad caps directly behind the core. This one doesn't. I think that's the thing that Gigabyte does with like 560 microfarad ones behind the core. But anyway, these three power boost thingies right here. So what they're meant to look like, I think, is prod lasers. And they might have prod lasers under them, but I'm pretty sure at some point I saw that these just look like prod lasers and actually just have another, I think, 6 SMD aluminum polymer capacitors under them. So I'm kind of assuming that's that because like prod lasers are a bit smaller than this. And just because I remember Zotac doing that, like putting this on top of like another couple SMD polymer capacitors. So I think there's another 6 in each of these, which just means that this card has an absurd amount of like actually a Hall of Fame level amount of SMD aluminum polymer capacitors. Then again, a Hall of Fame would have also an absurd amount of multi-layer ceramics and can-type capacitors too. Which this one doesn't. It only has a few multi-layer ceramics scattered here and there, and then no can types. But again, this is a 970. I'm not really aware of any other 970 that's actually made for like overclocking. So yeah, this is probably the best, just by being the only really overclocking focused card that was made. And I really like the output filter of this. This is a really, really nice filter. I would like that's kind of an outlier because that has nothing Zotac about it, except maybe the trying to make it look like they are prod lasers, but they're actually not. But this is actually just a really, really well designed, high quality, and probably also not very cheap output filter. So I really, really like that. So yeah. And I think now we can take a look here because we have some extreme overclocking focused things. So here it says LN2 OTP. That probably means LN2 over temperature protection. So you can probably just turn off the over temperature protection on this card. I don't know if the other switch does anything. There's an LED here. I think that lights up when you flip the switch. And then it says external power here, which I don't really know what that might mean. Yeah, I'm not sure if the second switch on this does anything. But that probably disables your over temperature protection. Then you have some voltage measurement points. So you can measure, you have a ground at 3.3 volts, a 12 volts, which doesn't specify which 12 volt power plane, because like every 8-pin has its own power plane, and then the PCI Express slot has another separate 12 volt power plane. So I don't know which one that is, or maybe it's just comparing all of them. Like it could be comparing all of them together, but that would need like some extra circuitry somewhere, and doesn't really make sense. Anyway, then you get core voltage, memory voltage, and PCIe probably prefers to the, what's it called? I forgot the name. PEX voltage. So a display drive rail that sometimes you overvolt, like usually overvolting this rail doesn't do anything except when you have like display dropout issues, when you are like really, really cold with LN2. And then there's some more LEDs here, which say MCU P8 P0. MCU, I'm not sure what that means. Yeah, I'm not sure what MCU means, but P8 and P0 probably indicate the power states. So it shows like which power state the card is in, which, okay, I guess that could be useful for something. It's not really an extreme overclocking feature that I think I've ever seen. I've seen like VRAM phase indicator LEDs, which this one doesn't seem to have. But hey, it's more extra stuff. And then we have this OC Plus header, which has a USB micro B connector. This thing is really cool, and probably confirms my suspicion about the NCP4008 supporting I2C, because this one, you just plug a USB cable into this, and then you can load up a software that Zotac had for the car. I don't know if you can still get it. I hope you can. But basically, this little box here, like you can see there's another like daughter board PCB or something. Like there's a lot of connections there. That's probably like a little daughter board. Basically what this is like a built-in EBC. So this thing gives you like voltage control and like a bunch of readouts about your VRM. That's really cool. I would have preferred if they also just like left a like I2C hookup point somewhere, like Asus sometimes does, to connect your actual EBC. But this is also really cool. I don't think it gives you all the stuff that you can do with an EBC, which is why I would have liked to see that extra connector. But yeah, this gives you voltage control and like some readouts of like probably voltage levels, probably like power consumption. It might give you LOC control. Like I can, if Deepa lets me, I'll test the card out a bit. If he lets me, I'll even like do a bit of Sub-Zero on it. But like again, would need his permission for that because he bought the card. I just have it because he bought it from eBay Germany and I happen to live here. So yeah, but this is a really, really cool thing. If you can get the software still. I don't know if you can still get the software. There's probably you can still get it. Like there's gotta be a save somewhere on the internet from this. But yeah, this is something that I don't think anybody else has ever attempted yet. Like EVGA has the EVBot header on some of their like Kingpin and classified cards, which is somewhat similar. Like if you have an EVBot, which was only like produced in low numbers and then Nvidia like made them stop production, so they are no longer being made for like a long time. So getting an EVBot is very, very hard. Then again, there might, I don't know if I remember this correctly, but I think at some point you could like use a Raspberry Pi as an EVBot by like hooking it up to the EVBot header. I don't know if I remember that correctly, but that might be a thing that you can just use a Raspberry Pi for that. So EVGA kind of had a similar thing, but they didn't have a such straightforward version of it. Like literally just connect USB cable to it and then load up their overclocking software and bam, you're going. Like no extra hardware purchase required, no extra like coding or building required if you go the Raspberry Pi road in case it exists. Like literally just USB start program and you have full like voltage control. That's really cool. I wish people kept doing it, like did that. I don't think Nvidia or AMD would let people do this these days. But this is such a cool thing. Maybe Intel lets board partners do like stuff when their graphics. Like I kind of have a hope that once Intel graphics cards come out, that Intel just like really lets AIBs do all kinds of crazy stuff, which would be really cool, and also probably would help them sell graphics cards because like it would get a lot of very positive publicity. So here's to hoping that they do that. But yeah, this is a really cool thing. I would love to test this out if Deepa lets me and if I can find the software. Yeah. So here's the GTX 970 AMP Omega from Zotac. I like it. Like, yeah, it is very Zotac with like the cheap VRAM components and like the fake VRAM phase right here. But that doesn't change that this is like a card that's made for extreme overclocking and probably can do extreme overclocking pretty well. Like, there's some cards that have some extreme overclocking features that like really don't do that well, mostly because those features are just kind of like tagged on there, and then the rest of the card is like just a reference PCB or something. But this is a card that probably just can do extreme overclocking. The reason why it's probably not well known is just because it's like that rare. I don't know if this one even... Yeah, this might like... I don't know where this came from. So there's a good chance that this might have come from like China, and then found its way here because the person that bought it sold it here. Because usually there's a lot of very crazy designs that you can get on graphics cards, especially from like Zotac and so on, that are only in the Asian market. So maybe this card originated from there, or maybe this is one of the few that you could buy here and just in very low numbers. But anyway, it's a really cool card. It's a card that I like. Like, it has the really good output filter. It has the built-in EVC. The fact that it's a 970 and not like a 980 or 980 Ti, like it's not a flagship or top-end card. Those are really cool things that I really like about it. So I'm a big fan of this card. Like, if this would have been a bit cheaper, I probably would have bought this card for myself. But I mean, well, now Deepa has a really cool card. He already has a 680 classified, so now he has another cool. Like, this one's probably cooler just because it's rarer, and yeah, probably because it's rarer, and like it's not a flagship card. Because like flagship cards get extreme overclocking designs pretty much all the time, but like slightly lower end cards, like this is still GM204, just like the 980. But you don't really see like extreme overclocking focused like 3080s or 3080 Ti's or like 2080s. Well, there were some 1080s, but that's because the 1080 Ti launched after the 1080 and not with the 1080, like Nvidia does it now. So yeah, I really appreciate it when manufacturers make extreme overclocking PCBs for cards that are not flagships, because it's still GM204, it's just as much fun, but you do it in a different ranking where it's like not that hard, where you like, yeah, don't go up against as many people, and yeah, and sometimes you also get like lower tier silicon, like a GM204, 204, no wait, this is a 204, a 206. Yeah, but I've been rambling now for, Jesus, 33 minutes. Yeah, so I should end the video here. Yeah, really like the card, really cool. Maybe you're gonna see some more content with it if Deepa like lets me do some things with it. Yeah, so he'll have a really cool card in a couple of days, maybe weeks, depends on when I can ship it to him. So yeah, so maybe he'll do some content on his YouTube channel. Like, he has a YouTube channel himself, just DIPA. Look it up. He just started out doing things, but well, I started out at some point too. So maybe he's gonna turn into a somewhat active and interesting overclocking channel at some point too. Anyway, thank you all for watching. I hope you enjoyed this look at a, as far as I know, pretty rare card. Like, probably on the same level as the 460 WHDI. Probably, if it's Asian market only. If it was sold in the EU and like in lower numbers, it might be a bit more common, but anyway. Yeah, hope you enjoyed, and until next time, goodbye.